Hey there guys, welcome to my channel. Today we're going to be solving a nice Diophantine equation where we have 1 over x plus 1 over y equals 1/3, and we're supposed to solve for integer values of x and y. Great, so let's go ahead and do that. First of all, let's go ahead and get a common denominator on the left-hand side. So if you do that, we're going to have x times y in the bottom and x plus y in the top. This equals 1/3. So we can cross and multiply and get 3x plus 3y equals x times y. Next, let's go ahead and move everything to the same side. So we're going to have 3x minus xy plus 3y equals 0. Next, let's go ahead and try to factor the left-hand side. And that's actually an idea whenever we have a Diophantine equation, an equation that we want to solve for integer solutions. So on the left-hand side, we can factor out x out of these two. So if you do that, we're going to have x times 3 minus y plus 3y equals 0. But as you can see, we cannot factor anymore because we don't have any common factor to pull it out. But if you look closely, we have 3 minus y over here. So if we can somehow create 3 minus y as a common factor over here, we can pull it out and we will be able to factor. So let's go ahead and do something interesting. Let's go ahead and subtract 9 and then add 9 to see the magic. So here's what I'm going to do. I'm going to go ahead and factor out a -3 out of these two. So once I do that, you're going to see why I'm doing this. So let's go ahead and factor out a -3 out of these two. So we're going to have -3 times 3 minus y. That's right? Look at it. It's right. Great. So we're going to have plus 9 equals 0. And now, if you look at this, it is obvious that we have 3 minus y as our common factor, so we can pull it out, and we will have 3 minus y times x minus 3 plus 9 equals 0. Cool. Next, let's go ahead and subtract 9 from both sides. So we're going to have 3 minus y times x minus 3 equals -9. And to make it a little bit cleaner, let's multiply everything by -1 to have y minus 3 times x minus 3 equals 9. Now remember that x and y are both integers, so x minus 3 and y minus 3 are integers as well. So let's go ahead and take a look at it on the right-hand side and see how can we build a product of two numbers that would equal to 9. So 9 is either equal to 1 times 9 or it is 3 times 3, right? Or it is -1 times -9 or it is -3 times -3, right? So we've got a bunch of scenarios. In the first one, I can go ahead and say that y minus 3 equals 1 and x minus 3 equals 9. In the next one, I can say that y minus 3 equals 9 and x minus 3 equals 1. Next one, I can say that y minus 3 and x minus 3 are both equal to 3. Next, I can say that y minus 3 equals -1 and x minus 3 equals -9. Next one is going to be -9 and -1. And the last one is going to be y minus 3 equals -3 and x minus 3 equals -3. So from the first one, I'm going to get y equals 4 and x equals 12. From the second one, I'm going to get y equals 4, actually y equals 12 and x equals 4, right? In the third one, I'm going to get y equals x equals 6. In the fourth one, we get y equals 2 and x equals -6. In the fifth one, we're going to get y equals -6 and x equals 2. And in the last one, we get x equals y equals 0, which is not valid because both x and y are in the denominator. Therefore, they cannot be equal to 0. And therefore, this is not a valid solution. So we have 1, 2, 3, 4, 5 pairs of solutions for x and y. And this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this and hit the like button if you enjoyed watching this. Hopefully I will see you later. Goodbye for now.